Dear students, today let us discuss few concepts based on complex numbers. Complex numbers is one of the smallest topic in your first PUC or 11th syllabus, but it is very important topic for joint entrance exams and CETs. Here in this, we have two parts, complex numbers and quadratic equations. Let me introduce you what is a complex number. Any number z which can be expressed as x plus iy is called as a complex number, where I is equal to root of minus 1. Z has got two parts. One is real part, another one is imaginary part. If I call z as x plus iy, real part of z is x and imaginary part of z is y. Let me explain you this here. Z is equal to x plus iy, then real part of z is x and imaginary part of z is y. Let me give you an example here. Let z is equal to 3 plus i4. What is real part of z? Is 3. Imaginary part of z is 4. This you should have already studied in your 10th standard or first PUC. Let me explain you what is conjugate of z. Conjugate of a complex number z is that complex number which when multiplied to the original complex number z gives you a positive real number. The shortest form of writing conjugate of complex number is this. If z is equal to x plus iy, then z bar is given by x minus iy. Look at this. If z is equal to x plus iy, then z bar is equal to x minus iy. Suppose z is equal to 3 plus i4, then z bar is equal to 3 minus i4 and vice versa. Suppose if I say z is equal to i5, then z bar is equal to minus i5. If z is equal to 5, z bar is not minus 5, remember it is 5 again. There are few properties of z that you should concentrate. Let me give you the list of very important properties of conjugate of a complex number. Let z is equal to a plus ib, then z bar is equal to a minus ib. Then z bar is equal to z. Z plus z bar is equal to 2a, that is equal to 2 times real part of z, which is purely real. Z minus z bar is equal to 2ib, that is equal to 2i times imaginary part of z, which is purely imaginary. Z bar is equal to a square plus b square, that is equal to mod z square. Z1 plus Z2 whole bar is equal to Z1 bar plus Z2 bar. Z1 minus Z2 whole bar is equal to Z1 bar minus Z2 bar. R into e power I theta whole bar is equal to R into e power minus I theta. Z1 by Z2 whole bar is equal to Z1 bar divided by Z2 bar, where Z2 is not equal to 0. Z power n bar is equal to Z bar power n. Z1 Z2 whole bar is equal to Z1 bar into Z2 bar. Modulus of Z1 plus Z2 whole square is equal to Z1 plus Z2 into Z1 plus Z2 bar. That is Z1 plus Z2 into Z1 bar plus Z2 bar, that is equal to mod Z1 square plus mod Z2 square plus Z1 Z2 bar plus Z1 bar Z2. Z plus Z bar is equal to 0 or Z is equal to minus Z bar. This implies Z is equal to 0 or Z is purely imaginary. Z is equal to Z bar implies Z is purely real. Very importantly, let me summarize whatever I have told, whatever I have listed just now. Let me summarize everything. Look at this. Z is equal to 3 plus I4, Z bar is equal to 3 minus I4. If I add these two, what happens? We will get Z plus Z bar as 3 plus 3, that is equal to 6. It is purely real. So very importantly, Z plus Z bar is 2x, which is purely real. And what happens if I say Z minus Z bar? Z is 3 plus I4. Z bar is 3 minus I4. If I subtract, I will get 4I4 plus I4, that is 2 times I4, that is equal to 2 times I4. Z minus Z bar is equal to 2 times I4, or I can write it as 2I times Y. Z minus Z bar is purely imaginary. And very important property of a conjugate of a complex number is this. Let me summarize all other properties in one single shot. Z1, Z2 plus Z3 divided by Z4 by Z5 minus Z6 whole bar is in simple terms given by Z1 bar, Z2 bar plus Z3 bar divided by Z4 bar whole divided by Z5 bar minus Z6 bar. This is one of the very important property. Maybe according to me, the simplest property in the entire mathematics is this. Conjugate, whether it is sum or difference or quotient or power. Even if you have Z1 power Z2, whole bar is equal to Z1 bar power Z2 bar. This is the easiest property in the entire mathematics. Coming to the next part, modulus of Z. What is modulus of Z? If Z is equal to x plus iy, Z bar is given by root of x square plus y square. I repeat, if Z is equal to x plus iy, modulus of Z is given by root of x square plus y square. Look at this. Z is equal to x plus iy, then mod Z is root of x square plus y square. If Z is equal to 3 plus I4, then mod Z is root of 3 square plus 4 square, that is equal to 5. And you can observe one thing. Z into Z bar is always given by Z into Z bar is always given by x plus iy into x minus iy, that is equal to x square plus y square. No doubt that is equal to root of x square plus y square whole square, that is no doubt equal to mod Z square. So one very important property which relates complex number and its conjugate and also its modulus is Z bar is equal to mod Z square. Let me give you a few more properties based on modulus of complex number. Properties of modulus of a complex number. Mod Z is always greater than or equal to 0, and mod Z is equal to 0 if and only if Z is equal to 0, that is x is equal to 0 and y is equal to 0. Real part of Z is always greater than or equal to minus of mod Z and less than or equal to plus mod Z. Imaginary part of Z is also greater than or equal to minus mod Z, less than or equal to plus mod Z. Mod Z is equal to mod of Z bar, that is equal to mod of minus Z, that is equal to mod of minus Z bar, and of course that is equal to root of x square plus y square. Z bar is equal to mod Z square. Mod of Z1 Z2 is equal to mod of Z1 into mod of Z2. Mod of Z1 by Z2 is equal to mod Z1 divided by mod Z2, provided mod Z2 is not equal to 0. Modulus of Z square is equal to mod Z whole square, or modulus of Z power n is equal to mod Z power n for all n belonging to n, set of natural numbers. Also mod of Z1 Z2 up to Zn is equal to mod Z1 into mod Z2 up to mod Zn. Mod Z is equal to 1, this implies Z bar is equal to 1 by Z, or Z is unimodular. z power minus 1 is equal to z bar divided by mod z square. Modulus of z1 plus or minus z2 is less than or equal to mod z1 plus mod z2. Modulus of z1 minus z2 is greater than mod of mod z1 minus mod z2. Mod of z1 plus z2 is greater than or equal to mod of mod z1 minus mod z2. Mod of z1 plus z2 whole square plus mod of z1 minus z2 whole square is equal to 2 times mod z1 square plus mod z2 square. Modulus of r into e power I theta is equal to r. Modulus of z1 plus r minus z2 square is equal to mod z1 square plus mod z2 square plus 2 times real part of z1 z2 bar.
CHIPS proudly announces admissions for crash course for JEE mains and CET coaching. Classes commence after 2nd PUC and 12th board exams. Crash course for 2nd PUC regular. Classes commence after 1st PUC and 11th board exams. Accommodation assistance provided for outstation candidates. Centers at Kumta, Dandeli and Bangalore.